Hi guys, I am Parsin from team Y30 from Y22, and I will be making this video on behalf of my teammates. So the problem statement from our team is the utilization of wind energy from different transportation systems to be used for the valuable purposes. So the idea proposed by our team is that the turbines can be installed at the top of cars, buses, trucks, and other vehicles so that they could generate electricity while running. So it's just like that. The wind will be concentrated towards the turbines, which will help it to rotate faster and thus increasing energy efficiency. So that there's a way that we could utilize the wind energy and we could utilize the wind energy for generating electricity through vehicles. And there is another way that we are representing that the windmills can also, or the turbines can also be embedded on large hot air balloons. So when they fly at relatively higher altitudes, something like this, so the large turbines can be fitted on the balloons so that the wind energy can be utilized. Typically, due to aerodynamic drag, there is a wind gradient in the wind flow, and specifically in the first few hundred meters of the Earth's surface, the surface layer of the planetary boundary layer. It's in the surface layer of the planetary boundary layer. So the wind speed increases with increasing height. So going up in the altitude, the pressure gradient between the warm air and the cold air will increase, which will help us to generate electricity. And this can be noticed by dash line for pressure being slanted more as the height is increased. Okay, so third, so this is also a way that we could generate electricity by using cars, like on different sideways. So the windmill or so the turbine can be fitted here, like this, something like this, and the wind can be concentrated towards the front or the side ends of the car and will be concentrated towards the windmill, and that's how it's work. And next, the formulation proposed idea. So we have demonstrated a concept of generating wind energy generation generation by using a lightweighted turbines made of lighter metals, like we are using a lighter material so that the energy efficiency could be increased. So like we could use aluminium and its alloys, which is the most efficient way, and they are uh, more relatively more lighter than other materials, so they could be used they're also, the commercial aircrafts are also using them. And we could also make another alloy from aluminium for these aircrafts, for these hot air balloons and turbines, so that we could easily embed them, or we could easily fly them up to the high altitudes and make them stable on the air. So the wind turns the propeller like blades or turbines around a rotor, which spins a generator, which creates electricity, and that's how basically a wind turbine works. So, so what's difference between this wind turbine or the windmill, which we are relatively using in nowadays? So the wind, so this wind hot air balloon can be transported from could be transported from one place to another, as according to the energy frequency. As we all know that there are certain wind currents on the atmosphere according to the movement, according to the rotation of the earth, and weather or temperature differs. So so the one that we are using today, we cannot transport it from one place to another, or we could not slightly change the place. We could rotate them, but we cannot change the place according to the wind frequency. But we can do all these things by using wind hot air balloons. So according to the wind frequency, we could shift them from one place to another, which will increase the efficiency and increase, and this will not take a place. Like, this is the biggest advantage of these hot air balloons, that these are on the sky and they will not need land, a large amount of land, or open area like this. So we could use in cities, also in metro cities, or in farms, or in villages, and everywhere we could use it. That's the biggest advantages of this project. So thank you for the days. It's all for this video. Thank you so much.